Mr. Taylor here. How's everybody doing? We want to take a look at Unit 5, Lesson 12.3, Explore Activity Number 2. We are still working with transformation, but this time we're looking and we'll utilize the properties of rotation. You will use trapezoid TRAP to investigate the properties of rotation. And again, the key vocabularies is rotation and center of rotation. And what I've done actually for you is on this page is I've put these particular properties here that we can understand when we're using a rotation. What do we do as far as our X and Y ordered pairs? And I think it'll make it simpler. So you might want to stop it and write your direction down here. It asks you to trace trapezoid on a piece of paper, include the portion of the X and Y axis bordering the third quadrant, and cut that out. And then it asks you to place your trapezoid on the axis on the top of those in the figure, and use them to help you rotate your trapezoid 180 degrees counterclockwise. I mean, here, remember, 90 degrees, 180. And please notice that your orientation for your vertices will change. Here, R will go up to here, P will go here, T will go here, and then they will change again when they get over here. So if you're going to do it manually, make sure you understand that. Do it quadrant by quadrant. Move it here first and then here. But if you're going to use the actual properties, the actual properties here, the change in X and the change in Y, then you just go directly to what it's asking us to do. C asks us to use the ruler to measure the size. By now we ought to understand that we're going to have same size for the once we do that, and then the actual image we'll definitely have the same size. And then the last one, well, actually D and E says use it to look at your we did just measure the image. Now look, the pre-image. Now look at the image and tell us what you notice. And then this one, F, G, and H, now take the protractor and get the actual measure of each angle. We got to notice that's 306 degrees, so we need to add up to 360. Look like to me we have two 90-degree angles in here, so these would be something other than 90 degrees. And here it says which sides are parallel, so now you're just going to look at, here's a side, is that parallel, or would these two be parallel? And then what do you notice? Alright, and then did I skip one? No. Okay, so then it says make a conjecture about your rotations. What happened to the size, the shape, what happened to the orientation, and place your tracing back in the original position. Then perform 180 degrees clockwise rotation. So that means once you put it back here, you're going to go here, and you go back here. Well, isn't that something? Then compare the results. Well, let's go ahead and get to work, so our 15 minutes don't quickly run up on us. If we were to trace, and I think that's what you're doing, you're going to do the tracing. I'm going to take a look at what the actual, if I looked at the properties here. So let's start with T. So if I have T, and I want to look at what's my ordered pair for T, I see 2, -5. Like that's 1, 2, 1, 2, 3, 4, 5. So I see X is 2. Well, let's see. I don't like that. Maybe I can just put them on the screen with it. Let's try it. See will that work. So I have 2, -5. That's not working either. So we won't write them. We'll just tell you what they are. I think the problem is just not having a big enough board. Tried it once with the computer, then trying it with the iPad. Still the same results as far as writing with the pen. So we're not gonna even stress. Okay, so I see that my T is 2, -5. It says if I'm going to go 180 degrees, I'm down here. And that's the case, it says that I should have, actually, it says X and Y. So, there we go. Let's go back. What are we doing? Okay, so it says my X and Y should both be negative. Okay, so now, let's see, I have 2, -5, so my T should be a -2, +5. So there it is. There is 1, 2, 1, 2, 3, 4, 5. So there's that point. Now my R, my preimage, is 2, 2. So I should have a negative, or the opposite and the opposite. So let's go with, should be X should be a negative. From positive it should change to negative, and from Y it should change to positive, because those are the opposite, and that's exactly where it goes. A, my preimage says 6 and a -2, so I should have, the 6 should turn to a -6, and the -2 should turn to a +2. So let's go and see. 1, 2, 3, 4, 5, 6. And -2. So there it is. +2 actually. -6, +2. And my P, let's look at P from the image, preimage standpoint. So I have 6. This is 7. So that's a +7 and a -5. So this should turn into a -7, +5. So let's go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, and it does. So using the properties, or actually, but like I said, if you're going to do it quadrant by quadrant with the trace, you got to make sure that you do these 90 degrees at a time, or take it, place it here, then place it here, or use the actual properties here. So as I went and looked at my ruler, I see that if I were to measure TR, RA, AP, and TP, I would get the same measure as TR, R prime, A prime, P prime, and T prime, P prime. And that should make sense to you, even if you just counted the units, which is I'm going to do. From T to R is 1, 2, 3 in the preimage, and then 1, 2, 3 in the image. From R to A, it's 1, 2, 3, 4. R prime to A prime, 1, 2, 3, 4, and so on. So they should, the measure, the actual length from TR to the image, preimage in the image, should be the same. All right, what do you notice about this length? And we just said that the length of the corresponding sides are the same. Then it asks us to use a protractor, and even with the protractor, if we did the measure of the actual preimage, which is these amounts right here, we will see you'll get 90, 90, 108, and 72, which will give us the 360 degrees that a trapezoid holds as far as the measure. Now, then if that's the case, then the prime will be, because T is congruent with T prime, so these measures will definitely be the same. And so again, that gives you your H. Whether you notice about the corresponding angles is they measure the same. Now, so then it goes down and asks us which side of the actual pre-image is parallel. This is definitely not parallel. Look at what that line is doing. It's slanting down. This one is more so of a vertical line, so these two are not parallel. This RA is running on y equals -2, and TP is running on y is a -5. Those lines will never meet. They are parallel, and that means 1, 2, well, 3 units. So let's go up and take a look. So if that's the case, R prime, A prime should be parallel, and T prime, P prime should be parallel. And that's what it says here. What do you notice? The sides were parallel in the pre-image, and they remain parallel in the image. Okay? Well, it tells us to go ahead and make a conjecture. Use your results from E, H, and I to make a conjecture about the rotation. Well, the author says what he sees is the size and the shape. The size and the shape remains the same. Well, actually, we could go a step further and say rotation preserves size, shape, or congruency. But the orientation change. If you notice here, P is running left with A, and T and R is T is down, R is up. But when we took it over, we have, and then RT is facing left. Here they are facing right, and PA, or they're facing right where they were facing left. But the orientation of the figure when we do rotation always change. And what it tells us, it says that, but the change does. Now it tells you, say, well, if you place this back and then perform 180 degrees clockwise, so that means you're going to go, instead of counting, you're going to go this way and back up here. Remember I said each quadrant gives you 90 degrees. So if you were to rotate it here, that's only 90 degrees. And if you rotate it again, that's 90 degrees. So what happens is P comes over here, T comes here, A, and then R. But so what happens if you do 180 degrees clockwise, look what it does. It gives you the same image. Don't believe me? Let's take a look. Same identical image. Okay? All right. So again, just really take your time on these properties. I think if you do that and then really get a clear understanding of what these properties are telling you to do, I think you'll be fine. This is Mr. Taylor, 13 minutes and 22 seconds. I'll see you soon.